Today we're going to talk about part 2 of our greatest integer function. Essentially what it is, it's a step function, which is one of our piecewise linear functions that has a bizarre looking graph. It's going to look really weird, and it's going to be a series of horizontal line segments. So this greatest integer function is one that we're going to use of the step functions. And this greatest integer function, understand that we'll write it weirdly. F of x equals little brackets here, which means that f of x is the greatest integer less than or equal to x. So no matter what the number is, we're going to take that number. Our input's going to be the x, but the output is going to be the greatest integer less than or equal to x. So we're going to round down. The key is we're going to round down. So for example, this is what the parent function looks like. This is what the mama function looks like. You'll notice this when x is 0, when y is 0, x is not equal to 1. So anything between here, so if I have 1/2, so if I go through it and if I put in for a table chart, if I put in for a table chart 0.5, it's going to round down below that, okay? So as I kind of go through this, it's going to round down all my values all the way through, so it's not going to include 1, okay? So 0.5 rounds to 0. 1 rounds to 1. I know it sounds weird. 1.5 rounds to 1. So what is the greatest integer that it rounds down to? It rounds down to 1. It can't include this. If I go on, 2 rounds to 2. That's the lowest, that's the least integer. 2.5 rounds to, you guessed it, 2. It doesn't make any sense. But when we're doing it, after you get the concept of just rounding down and accept that, then you're going to be okay. It's a disjointed line. They call it disjointed line segment. Okay. Understand that all functions, in order to be a function, you're essentially mapping one input to only one output. I cannot repeat my input. So here's my x value here. I cannot repeat this. X is open circle. Open circle means it does not include it. Here, open circle does not include it. So my x at 1 here does not include it. So 1, 0 is not included. However, 1, 1 is. So for this particular function, I'm able to graph 1, 1. However, if I go to 1.5 for my x, it's still going to be at 1 for the y. If I graph 2.5 for my x, it's still going to be at 2 for the y. So my output will still be rounding down. So this is my output. It's my output here. So if I put in 1.5 for 1 for my x, it stays at 1 for the y. If I put in 2.5 for x, so 2.5 for x, it still stays at 2 for the y. So understand that the concept of our step functions is that we're always going to round down. Looking at example 2 here, the outputs is, again, our greatest integer for graphing our greatest integer function. I have to look at this crazy function here. I take the f of x, and then I want the greatest integer of x plus 1. They want to state the domain and range. I have to find my domain first and my range first. So here's what you need to do. In order to do that, you have to first set up a table. We'll have x plus 1, and then we'll have to run the function of the rule of the greatest integer. So if I kind of go through this, you'll see if x is a -2, I put this in, a -2 plus 1 is going to be a -1. What is the greatest integer closest to -1? It's a -1. Don't forget, integers are going to be negative numbers that are whole numbers, 0, or positive numbers that are whole numbers. No decimals, no fractions. Okay? We want it to be nice and clean. No decimals, no fractions. Hello. Not that they're dirty. Okay. So if I had the integer, if I put in a -1.75, a -1.75 plus 1 is a -0.75. What is the greatest integer? Now I have to go lower for that. Be careful. Be careful. It's going to be -1 because on my number line itself, here is 0, here's a -1. What is less? -0.75 is going to go right over here, that direction right there. So it's going to be remember, it's the least greatest output. It's the least greatest integer. So if I have a -1.25 plus 1, it gives me a -0.25. And again, that adds up to what is the greatest, the least integer. I'm going to go to the least. I know it sounds weird, the least greatest integer. But a -1 is definitely less. If I go to 0, 0 is greater than that. So it's got to be lower. So it's going to be a -1. So I have to go backwards. Now, case in point, so put in a -1. A -1 plus 0. -1 plus 1 is 0. And so when I add that together, what's my the integer that's at least 1, that's going to be 0. So go through each one of these things and kind of talk it out loud like that. Okay, sorry, I put some in the classroom. All right, so go ahead and do the check right now. At least put in these values here real quick in the check. Oh no, what did I just do? Hang on. Nope. Okay, I gotta pause this sucker here. Oh, did I lose my recording? Oh, if I lost my recording, I'd be so upset. Embarrassing that I keep on losing the recording sign. Okay, so if you put in a -1 minus 2, you're going to get a -3. What is the, if it round down, the lowest integer, that'd be -3. Okay, so you always want to round down. -0.75, and -0.75 minus 2 is a -2.75. Again, I'm going down -3. And again, it's going further away from 0. It's the least. It's the the least integer that we happen to have. So, oh God, here we go. There's some music in the background. So go ahead and graph that. I'll check that in class. And that's all I wanted to share with you. Oh, wait. Next page. Sorry, I lied. Here's the next page here, which is our example of a stepwise function. And I think this one we'll go do it in class, but I want you to try and do the check, okay? Try and do the check on your own. Read through that and try and do the check on your own.